we are going to be talking about TCP, Transmission Control Protocol, and it is arguably one of the most important protocols that we use every time we're on the internet. And the purpose of it is to ensure the reliability and accuracy of data that is shared between a client and a server. So every time you web browse or send an email, or view a web page like the New York Times and you want to see an article, you want to make sure that, what the New York Times has published is what you're actually reading. And you also want to make sure that, like, when you send an email, your recipient gets the actual email that you sent and they're not getting some gibberish or, some misconstrued form of that. So basically the whole point of TCP is to ensure that we get this quality data that's received between these devices on the internet. So the key thing to note about a TCP connection is that it first starts with an initiation. And in this initiation, we have a three-way handshake. So let's say I'm trying to go to newyorktimes.com. So me, my client, I'm on my MacBook right now. I'm using Chrome, so my browser. Basically what we're going to do is we're going to send a TCP segment to the New York Times website. And inside of this TCP segment, I'm going to have a flag in that TCP segment with the SYN, S-Y-N, set to 1. And so basically that SYN flag means I want to connect. And so I send this SYN flag to the New York Times server, and their server responds to me. And what happens is, in their response, it's also another TCP segment, and they've set their SYN flag in that segment into 1, and then they also set the ACK flag to 1 as well. So they respond with a SYN ACK, which means I am available. And so basically that is them telling them, your browser, we can actually talk here. And then finally what happens is you, the client, respond to the server with a final ACK, and ACK just says, let's go, basically. So that is the three-way handshake that occurs in every single TCP connection in order to make sure that, both the client and the server are able to talk to each other. So after you've established your TCP connection, inside of all of these TCP segments, which are the fundamental units of data in a TCP connection, there are some unique properties associated with them. So all these TCP segments have a order, they also have a window, and they have checksums. And so, basically to break down what all that is, so the window of a TCP segment is if you, the client, are sending an email to someone else, what's happening on the back end in your computer is in this TCP connection, you're basically saying, I'm willing to send at most, 5 segments worth of data until I need to receive an acknowledgement from the server that they received it. And so if the server never tells me that they received it, then I need to retransmit these packets. So inside of that TCP segment, for the sake of making sure that we're reliably transmitting data, if for whatever reason data didn't make it from one place to the next, that's why we've got that window. With the checksum, it's a way of validating the integrity of the data itself. So, just like shipping a mug to one of your friends, you're telling them, like, I'm going to ship you 1 box, so they should expect to receive 1 box from you. Or maybe you have a set, so you're going to be telling them, I'm going to be shipping you 5 mugs in 5 boxes. So, if your grandma never actually says, I received the 5 boxes, well, then you're going to have to send the 5 boxes all over again. But the other part of this thing is, even though she gets the 5 boxes, the next question here is what to do about the mug itself, because maybe during transit, the mug shattered into a billion pieces and it's completely worthless to her. And so that's where checksums come into the picture. And not the greatest analogy, but basically a checksum, if you've heard of hashing functions, they're similar to it, where basically if I have a hash function, so we think of it like a black box. So we have a hash function. If I put in a string into this hash function, like ABC, I get an output, and it's going to be a series of numbers and letters and crazy characters, but it's like, 1, 0, 0, E, blah, blah, dot, dot, dot. You can look online at different hash generators But basically, the hash function is going to have a unique value to that input. And so the reason why this as a checksum is helpful is that basically you can think of this kind of like if you took a picture of the mug before you sent it to your grandma, you included a picture of the mug in the package so that when your grandma receives it, she has a picture of the mug to say like, okay, this is what the mug should look like, and I can see how the mug looks right now. Because during transit things can get messed up. So basically in this example, what we're doing by passing our data through this hash function is we are saying that when you take your data and you put into this hash function, this is the hash you will get out. And so when your server gets that data, the server will take the data that it received in that TCP segment. It will also run it through the same hash function algorithm that you did on your end, and it'll confirm that the hash output is the same thing, or the checksum is the same thing. And so if it isn't, then that means that something changed in the data, and so you need to resend this data to make sure that the recipient actually gets what you expected them to get. So that's the very important thing to note here. When you're sending this data is not just reliably, I got my 5 boxes to my grandma, but accurately, and that my mug didn't get broken along the way. So that is the importance of why we even do all this stuff in the first place. And finally, what happens when, let's say you're done sending all of your packets, your packages, your quote unquote TCP segments to your grandma. A very similar story happens to finish these things. And so what happens here is we will delete these, or we'll basically just change the words. So what happens when you're done is you will send a TCP segment with the fin flag set to 1. So I'm finished is basically what you're telling the person you're talking to. And then what happens, just like when we initiated it, is the server responds with a fin and an ACK. So they set the fin flag and the ACK flag to 1. And I'm ready to finish as well. And then finally, what happens at the very end is you send the server a final ACK saying, let's go, or whatever. We go our separate ways. But basically, that's how you terminate these TCP connections. So an important thing to note here is that for the value of having data transmitted reliably and accurately between these two computers, the cost here was that there was a lot of overhead and latency with setting up these TCP connections, closing these TCP connections, and also verifying the contents of every single TCP segment that went through our communication. Because if any of these segments were not transmitted correctly, then my client's can be resending these segments, and so it just creates a more computationally intensive way of communicating between devices. So that's why people have UDP, which is a different form of communication. And UDP is a lot easier to talk about because it's much simpler in that the alternative here is, instead of doing this kind of, let's initiate a communication and whatever, in a UDP setup, basically you have if we're trying to send a message, it just goes straight to the server. We don't even bother trying to send or initiate a connection with the server. We're just saying there's something on the network with this IP address, and I want to put this message on this port, and we'll hope that the server receives it. But the server will never even tell us that they received it, and so we don't have to even care. We're just in the business of spitting data out or receiving data, and that's it. So again, that's the trade-off, but the upside to that with UDP is that we now have a much faster, lower latency connection between these two devices, because it's there's just less stuff to process at the end of the day. So the use cases for this would be stuff like voice over IP, where I'm trying to talk to someone on the phone, and if they're like, I didn't quite catch what you just said, can you repeat yourself? Like, yeah, I can repeat myself. I don't really care that much about packet loss. Or video calls where it's more important to be able to have this data get through the CAN than to not, and so basically for the sake of having a lower overhead, lower costs, everything, that's why you're going to use UDP sometimes. So basically that's going to wrap things up for this video. I hope this is helpful stuff. Thanks all for watching, and let me know if you have any questions.